Hello students and welcome to Doppler effect part 2. Students, we had already done 4 conditions. Let us go ahead and see the 5th condition. Case 3a, where both source and observer are moving towards each other. So once again, the generalized formula can be given as follows. Now let us consider 2 cars that are moving towards each other. Now as you can see, there are 2 cars. They are going to move towards each other exactly this way. Now students, if both the cars have got observers and if both the cars are actually honking horns, the sound of the horn is going to increase. That means the apparent frequency increases. But now students, if the apparent frequency has to increase as per this formula, we should have a higher numerator and a lower denominator. That means the numerator increases and the denominator decreases. That means students, numerator can increase with a positive sign and denominator can decrease with a negative sign. So the formula gets modified to exactly this way. So students, every time you have the source and the observer moving towards each other, very clearly students, this is going to be the formula that you are going to apply. Let us have a look at the second side, where both source and observer are moving away from each other. That means in this case also the generalized formula is the same. Further, let us consider 2 cars that are going to move away from each other. So here we have, they are moving away from each other. Now students, if you would have carefully seen, when they are moving away from each other, the apparent frequency is going to decrease. If the apparent frequency has to decrease, the numerator has to decrease and the denominator has to increase. But how is it possible? The numerator can decrease with a negative sign and the denominator can decrease with a positive sign. So the final formula once again gets modified to exactly this way. And students, very carefully, in this case there is going to be a negative sign in the numerator and there is going to be a positive sign in the denominator. Students, these are the all possible cases of Doppler effect for our syllabus. Now further, let us have a look at the applications of Doppler effect. First application, color Doppler sonography gives the information about the rate of various fluids including blood. What happens is, the doctors incident ultrasonic sound waves on our body parts. Because of the fluids running inside our body, these ultrasonic sound waves get refracted. As they get refracted and are received, there is a part difference and there is a phase difference, because of which beats are heard, and based on the pattern of the beats we get the above pattern. This particular application is widely used in the medical industry, students. Let us have a look at the second case. It is used for speed detection by traffic police on highways. Traffic police have got speed guns that are set for a certain speed. That means if there is any vehicle which exceeds the speeds, what happens is beats are formed, and these beats in turn trigger a circuit that gives the alarm. Let us have a look at the next principle, students. Radar works on the principle of Doppler effect. How does it work? What happens is, in a radar, electromagnetic waves are continuously sent. Now suppose these electromagnetic waves hit an object, for example an approaching plane. So these waves are reflected back. There is once again a path difference because of the shape of the plane. That means from different parts of the plane, the electromagnetic waves are going to get reflected at different types. Once again we hear beats. Knowing the number of beats heard, we can actually calculate the velocity of the aeroplane and also the shape of the aeroplane. That is why even in cartoon movies, every time there are missiles coming towards your plane, you can actually see those missiles, how fast they are traveling towards you. Let us have a look at the next application. It can be used to determine the speed of the stars, students. So that means even the speed of the stars coming towards us, or say stars falling on the earth, or say asteroids hitting the earth, we can actually calculate their speeds by using the Doppler effect. It is also used to determine the speed of rotation of the sun and even other planets. Also students, let us have a look at the limitations of Doppler effect. The first limitation is Doppler effect is applicable when the velocities of the source of a sound and observer are much less than the velocity of the sound. The second and the most important limitation is the motion of both the observer and the source is along a same straight line. If you would have noticed, in all the cases we had both the observer as well as the source moving along a straight line only. That means if both are moving in multiple directions, it becomes difficult to apply the Doppler effect. Doppler effect needs modification depending upon the situations. That means, as we saw in point number 2, the directions change sometimes. Sometimes the medium might change. That means the velocity of the sound in different parts would be different. So even in that particular case, we are going to need modification, and these modification need to be very precise, students, because if these are not precise, what happens is the final results that we get go wrong. Thank you, students, and I will be seeing you for the next module.